Hello, this is Susan Poss. We are still working in Chapter 5. This is Section 5.5, and I'm going to try to do this whole section in one video and keep it so it's not too long. We are now multiplying polynomials. We just finished in the previous section adding and subtracting. So now that we're multiplying, we're going to be looking at multiplying the coefficients, not adding or subtracting them. And we'll be multiplying like bases, so this is where the exponents are going to add. So be sure that you watch these exponents as I work. So I'm going to do a couple of these. On the first one, I'm multiplying a negative by a negative, so that's going to give me a positive result. I'm multiplying the 6 by the 2, which is going to give me the 12. Then I notice these like bases, so I write the x down once, and remember this is where the exponents add. So we're going to end up with positive 12x to the 7th. All right, I'm dropping down underneath this, and we're going to see how the distributive property works. So on the first multiplication, I'm multiplying a negative 7x by a positive 12x to the 4th. So that gives me a negative sign. 7 times 2 is 14, and then this is an x to the first plus 4. I'll come back and straighten that out in just a minute. All right, on the next distribution, I'm multiplying a negative times a positive, which is a negative. 7 times 3 is 21, and this is x to the 1 plus 2, adding the exponents. And on the last multiplication, negative times positive is negative. 7 times 1 is 7, and this is just a single factor of x. So when I finish this up, it's going to be negative 14x to the 5th degree minus 21x to the 3rd degree minus 7x. And as we talked earlier, this is a 5th degree. This is a trinomial because it has 3 terms. And the lead coefficient is negative 14. So those are some vocabulary words just to remember. All right, so coming down and doing the one underneath that, I see a couple of things that need to be distributed. So I'm starting with 3a to the first times 3a to the first. These are both positive. That's going to give me a positive 9a to the 1 plus 1. The next distribution is going to give me a negative 15, and I still write down that a to the first. Moving to the second parentheses, positive 5 times positive 3a is positive 15a to the first, and positive 5 times negative 5 is negative 25, and there's no variable on that term. All right, so now I'm noticing that I have 2 terms here that are first degree terms, and let me go ahead and write this first one down. This turns out to be a to the 2nd, adding 1 plus 1 there. And then the 2 in the middle, positive 15a and negative 15a, add up to 0a, and remember we agreed before that when you have a 0 coefficient, this middle term just goes away. So we're going to end up here with 9a squared minus 25. And I'm going to go over here and do one more quickly. 3x to the first times 2x to the first, both positive. This is 6x to the 2nd, 1 plus 1. This is positive 3x. Notice I'm multiplying by negative here. That gives me a negative 4x and a negative 2. So this is a 6x to the 1 plus 1 to the 2nd power. These two are alike. They are like terms, so I'm going to combine those to get a negative 1x. You don't write that 1 down. And then minus 2. So this turns out to be a 2nd degree trinomial with a lead coefficient of 6. All right, so we're going to be working eventually with some that get much longer. This is a binomial multiplied by a trinomial. And so just to get you started, there's a little simple organizational process that's called using the box method. You can see I've written the trinomial across the top three columns across the top, and then the x and the -2 I've written along the side of the box. So here's how you work these. You take this first x and you're going to distribute it to each of the terms across the top of the box. So when I do x squared times x to the first, I get x to the third. Remember, those add up. When I do x times -3x, I get -3x to the second, because remember, these are both exponents of 1 and they do add together. And then when I do x times +7, I get +7x. All right, so that's my first row completed, multiplying by x. So now I'm going to come down to the second row here and multiply again across the top of the box by this -2. So now I'm doing, let me highlight as I work here, I'm doing -2 times x squared, which gives me -2x squared. I'm doing -2 times -3x, which is going to give me -6x. And then finally I'm doing -2 times +7, which gives me -14. So now you have to go back and look at all the boxes and see if you can find any like terms. So I see here along this diagonal, I see some x squared terms that are going to match up. And here along this diagonal, I see some x to the first degree that match up. And so remember, we're looking here for like terms. As we finish this up, we're combining like terms. So I'm copying down the x to the third. It does not have a match. The two I've highlighted in yellow will combine to give me -5. And notice this stays x squared because now I'm combining. The next two give me +1x. And remember, I don't write the 1. And then the last term is this -14. So you can see I end up with 4 terms here. This is called a third degree polynomial, and the lead coefficient here is 1 because you look for that coefficient out there on that highest degree term. All right, I'll do one more of these. Let's do this longer one here, because once you've seen one, I think you only need to see maybe one more. So I've taken one of the trinomials here. I've written it across the top of the box, and then the other trinomial I've written down the side on a vertical sort of plane here. So remember, I'm doing x to the second times x to the second, which gives me x to the fourth. Then I'm doing x to the second times +3x, which gives me +3x to the third. And then I'm doing x to the second times -1, which gives me -x squared. All right, so I'm going to take a little shortcut here. Let me show you where I'm working. -3x squared, now I'm going to distribute that over all of these. This is going to give me -3x to the third. I'm adding the 1 and the 2. This next one is going to give me -9x to the second. I'm adding the 1 and the 1. And then out here in this position on the far right column, I'm going to get +3x. All right, so finally, across the bottom row, I'm doing +1 times x squared, which of course is just x squared. +1 times 3x is just +3x. And +1 times -1 is -1. So again, I'm looking along these diagonals here for the like terms. And when you get accustomed to this, you will not put these things in a box. You'll work it out horizontally. But this is just to get you started with some of these longer problems. All right, so don't forget the x to the fourth up here. Here's our lead-off term because he's the highest degree. The ones I've highlighted in green there add up to 0x cubed. The ones I've highlighted in sort of that orange color looks like a negative 9x to the second. Remember, when we're combining like terms, the exponents do not change, just the coefficients combine. So I picked up all the pieces. Don't forget this minus 1 down here. So when you write this down, you don't want to write down the 0x cubed. You just want to skip over that. And so we end up here with a polynomial. It's got 4 terms of degree 4 with a lead coefficient of 1. And again, we don't write that 1 down. All right, let me show you one more that's just a binomial times a binomial. So we'll do x times 6x, 6x to the second. I'm adding the 1 plus 1. X times negative 1 is negative x. 2 times 6, negative 2 times 6x is negative 12x. And negative 2 times negative 1 is positive 2. And of course, these two are the only ones that match. So I'll end up with 6x squared minus 13x plus 2. This is a second degree trinomial with a lead coefficient of 1. And the last one, quickly, I'll do x times x, which is x squared, adding 1 plus 1. X times positive 2 is positive 2x. Negative 4 times x is negative 4x, and negative 4 times 2 is negative 8. And these two are the two that are alike. So x squared, these two combine to give me negative 2x, and then the negative 8. So we end up with a second degree trinomial with a lead coefficient of 1. Hope that helps.